So this video is going to focus on what are the different forms that we can have our square root function written in, and what do those forms look like whenever they are manipulated and changed so that the parameters are different values. So how will our graphs of these functions change? Our most basic form of a square root function is f of x is equal to the square root of x. Let's try that again. It's this function right here. So the rule of a square root function can be written in two different ways. This format we've actually worked with already, and if you watch the videos about parameters, a, b, h, and k are the parameters we've worked with so far. We can also change our form to this, and we're doing that by using this property, which we talked about in our last video. And this property works in this direction, but it also works in this direction. So if I have the root of a times b, I can also work backwards and separate it into two separate square roots, because it's possible that maybe the root of a or the root of b will give me a whole number rather than a decimal. So this is actually a lot easier to see if we take a minute to do a little bit of practice. So how do we change from one form to another? So let's say I have a function h of x, and I would like to change it from general form into standard form. Let's go back here. So right now, I'd like to basically find a way to remove the numbers in front of the x. So here I have 3 times the root of, and I'm going to change this term a little bit. I'm actually going to remove a negative 9 from both terms. So I end up with this. So I've removed a negative 9 from this term and a negative 9 from that term. And it's left me with negative 9 in brackets x minus 3, and the negative 3 on the end is still the same. So what can I do with that? I can actually use that property I showed you right here. And we can, oopsie, that's totally the wrong direction. And we can use that to remove that 9. Okay, so we're going to do this. 3, and I'm going to take this 9 and actually write it as its own separate square root. Because I'm allowed to do that. My property says that the root of a times the root of b is the same as the root of a times b. Well, that's what I've done here. I've taken my a times b, that 9 times negative x minus 3, and I've just separated them into two separate square root signs. What ends up happening there? Well, the square root of 9 is just 3. So I have 3 times 3, which is 9, root of negative x minus 3 minus 3. Okay, let's try another one. And I've done a terrible job here of picking numbers that are going to be really clear, but anyway, let's keep trying. So for this one, the 4 is actually already separated, so I can do this very quickly. I have 2 times the root of 4. I don't need to hold the microphone up to the board. You guys know I'm writing. And it looks like this when I separate it into two separate roots. How do I simplify this? Well, this just becomes 2, and it becomes 2 times 2, which gives me a 4. Times the square root of x minus 3, and it's still plus 1. So these are my two different versions of my function. So originally I had it written in my general form, where I had an a and a b, and I've switched them both into a standard form where I have just a value of a out in front of my root sign, and then I have a positive or a negative x in brackets with my k off of the end. So how do we graph a square root function? The first thing to know is basically what happens when we change the form of our square root function. Our basic looks like this. F of x is the root of x, and this is actually what the graph will look like here. This point down here at the bottom is at 0, 0 in our standard function, and that's our vertex. So what happens if we have that negative sign under the square root? Well, it becomes reflected around the y-axis. So our red function here, g of x, is a transformed version of our function. Let me try that again. This is a transformed version of our function. This is our basic. We can see the difference there. There's a negative under the root sign. This is how it will change in appearance. So the red graph here represents g of x, and the black represents our basic function. What about if we have a negative out in front of the root sign? In that case, we are reflected around the x-axis. So here the black represents my basic function again, and the purple represents g of x, which has been transformed by this negative sign out in the front. So if we have a negative a value, we can expect to see a reflection around that x-axis. If we have a value of a out in front of our root sign, what we see happening here, our basic function again is in black, and the orange represents the modified functions where we have 2 out in front. So we can see that we have been stretched vertically for this function. And our last one, if our graph is moved to the left or to the right, so in other words, if our h and our k have a value to them rather than 0, which is our standard, we can see here our basic function is in black, and it's the same as every other function we've worked with very recently in our parameters video, that if we have our x minus h in the brackets here, we can see that our h is 4, and that's true because we've moved to the right 4. And we have plus 3 for our k, and we can see that in fact we have been moved up 3. So we can tell that our vertex has moved from 0, 0 up to 4 and 3. So how do we graph a square root function? So now that we have an idea of what happens whenever we have different values in our standard form, we have to make sure, first of all, that it is written in this format. So we want to do a little bit of rearranging to make sure it is in that format. And if it is written in that way, then the vertex of our function is actually simply h and k. So we actually know automatically where we should start with our function. So if we have an example like this, g of x is 2 times the square root of x minus 5 plus 3, I can tell right away that my h and my k are 5 and 3. That means my vertex is located at 5 and 3. So let's create a table of values starting from 5 and 3 and moving upwards from there. So sorry about that, we had an announcement go off. So let's choose another point, and I'm going to make sure that whenever I choose my next point that I choose something that will give me a non-decimal. So I want to make sure that whatever minus 5 will give me something that I can take the square root of. So I'm going to choose 9. So I have 9 minus 5, which gives me 4. So I end up with 2 times by the square root of 9 minus 5, which is 4, plus 3. Well, the square root of 4 is 2. So 2 times 2 plus 3. So 4 plus 3, which will give me 7. I'm going to choose one more value to graph. I'm going to choose 14. You'll see why. So 2 times by the square root of 14 minus 5 is 9 plus 3. So I end up with 2 times the square root of 9, which is 2 times 3 plus 3. So 6 plus 3, which will give me a 9. And I've cheated a little bit. I've already made the graph for you. So when I graph these points, I end up with a root function that looks like this.